Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video, we completed the chapter called Application of Derivatives. That completes first part of our second PUC mathematics. Now students, in today's video, let us start at 7th chapter of second PUC, that is a part 2 of our second PUC mathematics textbooks. And in that, the first chapter is integration, and also we can call it as 7th chapter of our second PUC mathematics, that is integration. It is the 7th chapter in our second PUC mathematics, as well as this is the first chapter in part 2 of PUC mathematics. Integration. So students, first let us try to understand what is the meaning of integration. Student, the meaning of integration is very simple. It is just addition. Addition, or it is also called as sum. Sum. This is the general meaning of integration. That is addition or sum. So integration means we are just adding. Then next, let us see the definition of integration. What is the definition of integration? The definition of integration is, it is a reverse process of differentiation. It is a reverse process of differentiation. It is the reverse process of differentiation, or it is also called as antiderivative. The other name of integration is antiderivative. Antiderivatives. The other name of integration is antiderivatives, and its simple definition is, it is a reverse process of differentiation. So whatever we did in differentiation, we will take the reverse process of that. How it is reverse process, I will explain later. So in integration, students, there are basically two parts in integration. In that, the first part is indefinite integration. Indefinite integral, and the second part is definite integral. Definite integrals. There is a slight difference between indefinite and definite integral. So students, since it is our beginning class, so let us start with indefinite integrals. So first is indefinite integrals. What is indefinite integrals? As I said, student, integration is nothing but, it is just a sum of the functions, or sum of the any event, sum of the any quantities. Wherever we consider the concept of sum or addition, in general it is considered as integration. We can also call it as integration. Now what exactly we will do in integration, and where we will use the integration is mainly finding the area of the regions, area of the region bounded by the curve, or area of the curve. For example, uh, if I have a curve like this, I have a curve like this, and if I want to find the area of this curve under this curve, if I want to find the area under the curve, in this case we will use integration. We will use the integration to find the area under the curve or area bounded between the regions. So how exactly we will find here is, we have a bigger area here, that much is quite difficult us to find. So this bigger area we will convert it to smaller parts. How do I convert it to smaller parts? I will show you a picture here. This is the smaller portion of this area under the curve. Now, since there is a slight in x-axis, slight gap in these two lines, this gap is called as dx, since it is on x-axis. This is x2 and this is x1. This is our x2 and this is our x1. That is x2 minus x1 is dx. Then we can easily observe that it exactly looks like a rectangle. This portion is look like a rectangle here. So since this is dx on x-axis, if I start measuring this on y-axis, then somewhere it will come like this. This I can call as y, or this I can also call as f of x. Y or f of x, both are same here. Now students, it is easy to find the area of rectangle. We studied from our lower classes, the formula to find area of this rectangle is length into breadth. Length into breadth. And we know that the length of this figure is y, because we consider the distance from here to here, it is y, and here it is dx. So area of rectangle is y into dx, that is length into breadth. That is area of this rectangle. But student, our interest is to find the area under this curve. The area under this curve, that is from here to here. So what exactly we should do now? For that, we will take the again smaller portions here. We will take the smaller portion. As I took one portion here, I will take one more portion. Then I will take one more portion. Then I will take one more portion. Then here also, I will take one more smaller portion, one more smaller. Then I will start finding the area of each rectangles. See here? I can start finding the area of each rectangle. There are many rectangles here. As you can see here, this is the rectangle. This is the rectangle. This is the first, second, third, fourth, fifth, sixth, seventh, eighth. There are totally 8 rectangles are there. Just to show you, I just draw the figure like this. Now how to find this complete area? That time we will take integration here. Understand? This is the symbol of integration. The symbol of integration is just like this. As I said, integration is nothing but sum. Just this, yes, we stretched in both the directions. Upper and lower direction we stretch, then we get like this. So this represents sum. So what is integration will do here? We will find the area of the geometrical figures, especially area under the curve or area bounded between the regions. So what exactly, how exactly we will represent it? We will represent integral y dx, or integral, this is integral f of x dx. So student, this is the basic concepts of integration. Now as we discussed indefinite integral, so student, in indefinite integral, whatever the answer we will get, that is an indefinite answer. Means that is not the correct answer. In this kind of indefinite integral, this is indefinite integral. The reason we will tell this is an indefinite integral is we don't have limits here. We don't have this kind of limits. That is from 2. So because of that reason, we will tell that it is indefinite. Means we don't know from where to where we should find. How long we should find this, from where we should start and where we should end. That is not specified here. So it is called as indefinite. And in indefinite integrals, whatever the answer we will get, that is not the definite answer. That is also indefinite answer. So how do we find the exactly correct answer is depends on the integral constant. The answer of this integral function is purely depends on the integral constant. And here in integral, the integral constant is c. C is the integral constant. In general we denote. What is this c is? C is any real number. For all this c belongs to R. C is any real number. This c we should add to the answer of indefinite integral. Then according to the values of c, we will declare the answer. As the value of c changes, the answers will also change. That's why it is called as indefinite integral. For example, how we will represent this? If I have integral of sin x dx. Sin x is a function, dx is with respect to that. Now, in the above, I said integration is reverse process of differentiation. It means in my integration, I should get the answer as differentiation. If differentiation is a question, integration should be the answer. Or it is reverse case, vice versa. If integration is a question, then differentiation should be the answer. Now here, we know that in differentiation, we studied derivatives of trigonometric function and some other functions also. Here I have taken integration of sin x. We know that derivative of sin is cos. And derivative of cos is minus sin x. Since we are taking integration of sin x, its answer should be minus cos x. Minus cos x, because sin x and its integration is minus cos x. Because if I differentiate this, I should get this as answer. But here there is a problem. This is not the final answer. This minus cos x is not the final answer for integration of sin x dx. The reason is this is indefinite integral. And in indefinite integral we should add c to the answer. Then we will get the final answer. So this minus cos x should be added to integral constant c. Now this complete gives the answer of integration of sin x. Now if I differentiate, definitely I will get sin x. You can check. So I will do it here. D by dx of minus cos x plus c. C is a constant. Minus, as it is, derivative of cos x. Derivative of cos x is very much familiar to us. It is minus sin x plus derivative of c is 0 because c is constant here. So this minus into minus is plus sin x as it is. So student, we can easily compare that integration and differentiation. Here, this integration and differentiation is the reverse process, and integration is also called as antiderivative. Integration is also called as antiderivatives. You can easily get an idea from this example. Okay students, after the basic concepts of integration, let us see the standard formulas of integration, because without those integration formulas we cannot solve the problems. As we need derivatives of trigonometric functions, algebraic functions, logarithmic and exponential function, we should know the formulas of integration with respect to trigonometric function, with respect to algebraic, with respect to log and exponentials. Let us see the formulas first, then we will start the problems. Formulas of integration. First, and before I go to formulas, let me tell you one more thing about integration. In differentiation, we have seen that the function will get reduced. The function will get reduced. How it is reduced? Suppose if you are taking the derivative of x power n, if you are taking the derivative of x power n, here this is n and it is represents the power of x, the order of x. So n is order of x or degree of x. Now here if we differentiate, I will get n into x power n minus 1. The degree of x is reduced here. After differentiation, the degree of x is reduced. Means the function is getting decreases. The function is reducing. Whereas in integration, the function will get increase. The power of x will be increase. That's why we will tell that in integration it is adding. We are increasing in integration. Whereas in differentiation, we are dividing, we are removing. So, the formula of integration of x power n with respect to dx will be x power n plus 1 divided by n plus 1. So, the power of x is increased. So, it is adding. Obviously, plus c we should write. Plus c. Integral constant is very, very important. As the value of c changes, the answer will also get changes. Second, then integration of k into dx. K is any constant, then that will become k into x plus c. Because integration derivative of constant is 0, here integration of constant is constant into the variable. Whatever the variable we are integrating, we will take that variable. We are integrating with respect to x here. Now here we will take variable x with k. Third, integration of 1 by x dx. Derivative of log x is 1 by x. Then obviously integration of 1 by x is log x plus c. Fourth, integration of e power x dx is e power x plus c. Then fifth, integration of root x dx is root x is x power half, because root means x power half. So according to that, we will write this as 2 by 3 into x root x plus c, or we can also call it as x power 3 by 2. X power 3 by 2, we can also write this as 2 by 3 into x power 3 by 2 plus c. Both are same. Here just I splitted 3 by 2. 1 plus half. Or here directly I have taken x power 3 by 2. Both are same formulas, same answer for integration of root x. Next, integration of a power x dx. Here it is a power x divided by log a, divided by log a. Then next is integration of e power ax dx is e power ax divided by a plus c. And next is integration of sin x dx is minus cos x plus c. And next is integration of cos x dx, that is equals to sin x plus c. Next, integration of tan x. Tan x dx is equals to minus log of cos x plus c is there obviously, so it is minus log of cos x. I use brackets here. Or integration of tan x has one more formula. This can also be written as log of secant x, because if we differentiate these two functions we will get tan x. So integration of tan x is either minus log cos x or log secant x plus c. Then next is integration of secant x dx. This is equals to log of mod secant x plus tan x. This integration of secant x is log of, with mod we should take this secant x plus tan x. Next is integration of cot x dx. This is equals to log of sin x. So integration of cot x is log of sin x, because if we differentiate this we will get cot x. Next, integration of cosecant x dx is equals to log of mod cosecant x minus cot x. And next, there are some other integral formulas related to trigonometry. Integration of secant square x dx. We know that derivative of tan x is secant square x. Then definitely integration of secant square x is tan x. Of course plus c's are there, so you must write plus c also. In problems at the end, after integration, in each and every indefinite integral problem, we should write plus c. The next, integration of cosecant square x dx is equals to minus cot x. Next, so here, if I take any multiple angles with trigonometry, like sine AX dx. So in differentiation, we have seen whenever we are taking multiple angles with trigonometry, then whatever the value multiplied to x, that will be multiplied to the derivative of the function. For example, if I take derivative of sine AX, we used to write a into derivative of sine x, sine AX. That is a into cos AX. Means this constant or coefficient of x, we used to multiply to its derivative. Now here in integration, whatever the multiple angle comes here, whether it is negative, positive, whatever it is, that must come in the denominator of the integral. Denominator of the integral. That is, integral of sine AX is minus cos AX. Since a is multiplied to x, that must come in the denominator of this. Of course, plus c is there here. It is like this. So for every function, wherever multiple angle comes, we should be very careful that we must write that value in denominator after integration. And student, wherever there is no integral for any function, if there is no integral for a particular function, that time we must use identities. For example, here I have taken secant square x dx. What if it is tan square x? How should I write the integral of tan square x? Because let us see, what if it is integral of tan square x? Integral of tan square x. In that case, student, since it doesn't have any integration, what we should do is, we will use trigonometric identities. Trigonometric identities, and in one of the identities says that tan square is equals to secant square x minus 1. Secant square x minus 1. Now we can easily integrate this instead of this, because this we don't have direct integration. So what exactly we should do? Whenever a function comes under integral which doesn't have any integration, so we should convert into its other form by using trigonometric formulas or trigonometric identities, as I converted here with the help of identities. Now I can easily integrate this. There are two terms under this, so one by one we will integrate. What is integration of secant square x? We have seen here it is tan x. Minus, what is integration of any constant? One is a constant here. Constant into x. So 1 into x. It is x. Obviously plus c. Like this. So what is the integration of tan square x? It is tan x minus x plus c. So student, these are the basic formulas of trigonometry integration. You must know at least these many formulas are related to this, and of course there are other formulas. We will take it now. So that is integration of 1 divided by root of 1 minus x square dx. It is obviously sin inverse x plus c, because we know derivative of sin inverse x is this. Then next is integration of minus 1 divided by root of 1 minus x square dx is Obviously it is cos inverse x plus c. Next, integration of 1 divided by 1 plus x square into dx is tan inverse x plus c. And of course students, other formulas you people can easily write. That is 21 is integration of r1 into dx is dx divided by x into root of x square minus 1. This is equals to secant inverse x plus c. And if we take negatives, we will take cosecant inverse. And here if we take negative, we will get cot inverse. Students, I hope I have given all the formulas of integration. You try to memorize these formulas. If you memorize these many formulas, or if you get an idea of these kind of formulas and other formulas, definitely we can solve the integration problems without any difficulties. Okay students, now let us try to solve some problems and we will see how can we solve the problems. And that it is problem based on first exercise, that is exercise 7.1. We will try to solve problems of 7.1 exercise. So here the first problem is find the integral of sine 3x. Let's just ask the question. Find the integral of sine 3x. So integral is represented by capital I here. So we'll start the answer. I is represented for integration, that is capital I. This is equals to, we said integration of sine 3x with respect to x. So we can write this as integral into sine 3x into dx. Now student, it is exactly in the form of sine ax and it is a multiple angle. So sine 3x, this 3 is multiplied to x. Now in its integral, this 3 must come in the denominator. So what is the integration of sine? It is minus cos, angle remains same here, 3x means 3x. But whole divided by this 3 must come in the denominator plus c. This is the final answer of this question. This plus c is very important students. You cannot forget this plus c because our answer is purely depends on plus c. As the value of c changes, the value of this function will get changed. The answer will get changed. And c is real number. The second question is find the integral of cos 2x. Should find the integral of cos 2x. Again, this can be represented like this, I, that is integral, and it is equals to integration of cos 2x dx. Now, again it is multiple angle. So what is the integration of cos? You should be very careful in integration and differentiation formulas. Generally students will get confused in integration because they already studied differentiation. And same formulas will expect in integration also. It is totally wrong. You should be very much good in formulas. If you have a little bit confusion in formulas, then you may get wrong answers here. So integration of cos 2x is, it is sine 2x all divided by 2 plus c. Next, find the integral of ax plus b whole square. We should find the integral of ax plus b whole square. Student, here integral of ax plus b whole square into dx is equals. First what we will do, we will apply the formula of a plus b whole square concept. Then we will integrate term by term. So what is a plus b whole square formula says here? Ax whole square plus b square plus 2ab into x with respect to dx, with respect to x. Now there are totally 3 terms, but let us write the term properly here. So I is equals to integral of a square x square plus b square plus 2ab into x with respect to x. Now yes student, these 3 terms we should integrate, and under integration if any coefficient comes to x or whatever the integral function, that we will take out of the integration, because this is a coefficient, we cannot integrate this. So a square is out of the integration into x square, this dx is multiplied to this, plus b square, it is a constant, so integration of b square into dx plus 2ab is a coefficient, 2ab is out of the integral, x dx. Now let us integrate this. A square as it is, integration of x square, it is taken, we will take it in terms of x power n. So integration of x power n says that n plus 1 divided by n plus 1. According to that, this will become x plus x power 2 plus 1 divided by 2 plus 1, that is x cube by 3, plus integration of any constant is constant into variable, and your variable is x, constant as it is, plus 2ab is as it is because we are taken out of the integral. Integration of x, integration of x means let us consider it is x power 1. So as we did integral here x square, so according to that, integration of x power 1 is x square divided by 2. Since integration is over here, so after that we should put plus c. After integration, this denominator and numerator 2 gets cancelled. So the final answer here is a square x cube by 3 plus b square into x plus a into b x square plus c. This is the final answer. Okay students, let us go to the next problem. Find the integral of sin 4x minus e power 3x. Sin 4x minus e power 3x. There are 2 terms here. We should integrate one by one. So this can be written as, we can easily write this as integration of sin 4x minus e power 3x, in bracket it is dx. If you want, we can write separately, or we can merge like this, and once we can write dx. First, integration of sin 4x. Integration of sin 4x is minus cos 4x whole divided by 4 minus as it is e power ax. What is e power ax? E power ax divided by a plus c. We can stop here, no need to take any LCM. So this will be the last answer. Next, find the integral of 2x cube plus 4 e power 3x plus root x. There are totally 3 terms here. He is asking us to find the integral of these 3 terms. We'll take integral, that is I is equals to integration of 2x cube plus 4 e power 3x plus root x into dx. One by one. Here 2 is a coefficient, so I'll write outside the integral. Directly we'll integrate x cube. The integration of x cube is x power 4 divided by 4 plus 4 is as it is, coefficient to this function as it is. Now integration of e power 3x. As we saw here, e power 3x integration is e power 3x divided by 3 plus integration of root x. Root is nothing but x power half. It is 3 by 2 into x power 3. So it is 2 by 3. 2 by 3 into x power 3 by 2. After integration, you must write plus c. Now here this and this gets cancelled 2 times. So the final answer is x power 4 by 2 plus 4 by 3 e power 3x plus 2 by 3 x power 3 by 2 plus c. That is, find the integral of x cube plus 3x minus 4 whole divided by root x. So this time there is a denominator here. So this can be written as I is equals to integral of x cube plus 3x minus 4 all divided by root x dx. This root x is divided to complete numerator, and in numerator there are 3 terms. So for all these 3 terms we should divide root x. So this will be integration of x cube divided by root x plus 3 into x divided by root x minus 4 divided by root x. It is like this. Now after splitting this, x power 3 and it is x power half in the denominator. X power 3 and x power root x means x power half in the denominator. According to that, if it is like this, if a power m divided by a power n, then according to indices this can be written as a power m minus n. I'll apply the same concept here. So integral of x power 3 minus half, because root x means x power half in the denominator, that is shifted to numerator, then the power becomes minus. So it is x power 3 minus half plus 3 as it is, and we know that x divided by root x is nothing but simply root x. How can we write root x for this? X can be written as root x into root x divided by root x as it is, or we can take root x whole square for x. Now one time root x gets cancelled, finally it is root x. So wherever we get x divided by root x, there we can write simply root x or x power half minus 4 x power root x. Root x means x power half, and if we shift to numerator, it is x power minus half into dx. I hope you people understood this step, because here denominator I shifted to numerator, then power will automatically changes. Now 3 minus half x power 6 minus 1, LCM is 5 by 2. 2 is the LCM, 2 into 3 is 6, minus 1, 5 divided by 2, plus 3 root x means x power half minus 4 x power minus half into dx. Now let us integrate these three terms. Actual problem is this. This we simplified to like this. Now after simplification, let us integrate one by one. X power 5, same formula as x power n. So x power 5 by 2 plus 1 divided by 5 by 2 plus 1 plus 3 x power half plus 1 divided by half plus 1 minus 4 x power minus half plus 1 divided by minus half plus 1. After integration we must write plus c. Again 2 is a LCM here also. So 2 plus 1, sorry 2 into 1, 2, 2 plus 5, it is 7, and denominator it is 7 by 2, so that can be written as 2 by 7 because it is 1 divided by 7 by 2, so that is reciprocal of 7 by 2 is 2 by 7 into x power 7 by 2 plus 3 into, it is 3 by 2, that means 2 by 3 x power 3 by 2 here minus 4 into minus half plus 1 is plus half, so this is reciprocal of half is 2 into x power half plus c. So finally the answer is 2 by 7 into x power 7 by 2 plus 2 into x power 3 by 2 minus 8 into x power half plus c. Okay students, let us go to the next problem. Find the integral of secant x into secant x plus tan x dx. I'm sorry, there is no dx here. So this can be written as I is equals to integral of secant x into secant x plus tan x dx. We can write here because we are integrating here. We just ask find the integral of this function with respect to x. So that can be written like this. Now let us multiply these two things. So secant into secant is secant square x plus secant into tan is secant x into tan x into dx as it is. What is the integration of secant square x? We have direct integration of secant square x. Its answer is simply it is tan x plus as it is now. Integration of secant x into tan x. If we don't have any formula for this, let us convert this in terms of derivative. Is there any function whose derivative will be secant x into tan x? Any function whose derivative will be secant x into tan x? Yes, obviously. Derivative of secant x. Derivative of secant x is secant x into tan x. Then integration of secant x tan x is secant x plus c. So after integration these two terms we will get this is the answer. This is integration of secant square, that is tan x, and this we got it after integrating secant x tan x plus c is constant. Next, Find the integral of secant square x divided by cosecant square x with respect to x. We should find the integral of secant square x divided by cosecant square x into dx. Student, we don't have any integral for this. So what we will do here is, we will apply trigonometry. How can you apply trigonometry here? Integration of secant square x divided by cosecant square x dx. Let us take the other trigonometric functions related to this. Cosecant square is in denominator, that I can consider as 1 by cosecant square, and we know that in trigonometry 1 by cosecant is sine. So this can be written as sine square x. That is 1 by cosecant square x can be written as sine square. Now the reciprocal of secant x is 1 by cos. So since secant square is in numerator, so this can be written as 1 by cos square x dx. Whatever the question is given, that same question I converted to this particular form. Now this will be very easy for me, and this is very familiar formula. Sin by cos is nothing but tan. So it is integration of tan square x dx. But this creates a problem. We don't have any formula of tan square x, any integral of tan square x. But we can convert this to identity as I shown in the formulas. So this can be written as, I will write the rough work here. The identity I am applying is tan square x plus 1 is equals to secant square x. This is the identity we will apply for integration of tan square. So first we will convert it to proper form, then we will take the integral. So what is just tan square? Tan square x is equals to secant square x minus 1. Secant square x minus 1 is the value of tan square. So instead of integrating tan square, let us integrate secant square x minus 1. So this is equals to secant square x minus 1 into dx. What is the integration of secant square x? It is simple, just tan x minus integration of any constant, or that is integration of 1 is 1x plus c. Very simple. Okay, since let us take one more problem here. Find the integral of 2 minus 3 sin x divided by cos square x with respect to x. This time our numerator has 2 terms, denominator is 1 term. So first let us convert this to proper form, simple form. How can we write this in simple form? Let us split the terms, because denominator is only 1 term, numerator has 2 terms. So let us first split it. So how can I split? 2 by cos square x. Splitting means we are dividing the numerator with this cos square x. 2 divided by cos square x minus 3 sin x divided by cos square x into dx. It is like this. After this, as we applied the trigonometry in the last problem, similar trigonometry will apply here. Integral 2 as it is 1 by cos square is secant square x minus 3. Cos square x is 2 times, cos is 2 times in denominator, that's why it is cos square. Sin is exists in the numerator only 1 time. So sin I will mix with 1 time cos, so that I can read as sin by cos, or I will write like this: sin x divided by cos x into cos s. So no student should get confused here. So I will write cos square x as cos x into cos x. Now I will mix this numerator sin x with this cos x. Then again separately I will take 1 by cos x. So this is integral 2 secant square x minus 3 sin by cos tan into, nothing is there means 1 will be there always, 1 divided by cos. 1 by cos is secant x, close the bracket, into dx. Now I think it is very simple. Now we can integrate this. These 2 and 3 are the coefficient to these functions. We will take outside the integral. But term by term, there are 2 terms under the integral. We will integrate 1 by 1. First I will integrate this. So if I am integrating this, I will take 2 outside the integral. Integration of secant square x dx minus, I will take 3 outside the integral, tan x into secant x dx. Now integration of secant square x is very simple. It is tan x minus 3 as it is. Then integration of tan x into secant x or secant x into tan x. As we did in the previous problem, it is secant x. Obviously, at last, plus c. This is the final answer. Students, this is about our first exercise in integration. If you have any kind of doubt in today's video, you can put your doubts in chat box. Inshallah, I will try my level best to solve your doubts. If you are new to this channel, don't forget to subscribe our channel and keep sharing our videos so all the students can be benefited with this. Thank you, student.